Chapter 11, Randomness.
What the heck? Random and then we just call it
How am I supposed
Collecting
to Did we do chapter 10?
data.
We
We
skipped
just
it,
did
right?
those like questions and called it a day. Cause
Wait.
yeah. If
It's gonna die.
we want to, we'll be all right. Generate data that gives an accurate picture of the world. We must rely on randomness.
No. I don't like the sound of this, I'm not gonna lie. Not the sound of this, but like the sound of that. For that you're gonna kick my desk.
We can get random numbers through random number tables. Computer number generators, which your calculator can also do. Dice, etc. All right, building a simulation. Using randomness to predict an outcome. This is going to have 7 steps. 1, identify the repeated component. 2, explain how you will model the component's outcome. 3, specify how you will combine components to model a trial. State clearly what the response variable is. 5, run several trials. 6, collect and summarize the results of the trials. And last but not least, state your conclusion in context.
How you know movie medium? Because I can see you in my peripheral vision over there. Yeah, that's pretty dyslexic. I am dyslexic. Yeah. Mm-hmm. Stop moving around my water bottle. Creeps me out. She turned her head around.
Alright, so the next thing we're going to do, I'm going to let y'all get these down, is we're going to walk through an example together of what this will look like. We'll actually do it, like, actually running trials when we go through and do the worksheets that go with these. But basically, you're just going to take that I've run these trials for this problem that I'm going to do, and we're just going to take it as it is. Just so you have something to kind of look at, and then we'll actually do it for the problems in the notes.
So we're done
examples,
with the notes
I mean.
and now we're doing examples.
Well, sort of. This is an example in the notes. So it's going to, like, explain things a little bit as we go differently.
Oh no. Oh no. Oh my goodness gracious.
Why is it taking so long to write, Maddie? Are you slow?
Yeah. I started later. Why was that?
I don't remember. Were you being mean?
Was I what?
Being mean? Is that why?
No, I don't think that was mean. I was mean throughout it and I still managed to finish. Did you?
Alright, I'm going to start writing out the example, and then that way y'all can copy that down, and then we'll go from there.
Quite comfortable.
Alright.
Why don't you go that way then?
A candy company is giving away a prize to consumers who collect a red, a white, and a blue game piece. Sounds like Willy Wonka. From their candy bars. Each bar has one game piece in it.
Whoa, isn't that a choking hazard?
It's like how a prize comes in a box of cereal. Y'all might not even be old enough to remember prizes coming in cereal boxes.
I do. But,
I used to know.
but how do they put it in the candy bar?
And just take the prize out.
Like on the outside of the bar?
It's probably like in a box.
Have you never seen Willy Wonka?
Yes. You know what, Berkeley? I want you
It's
to
like a
stop
golden
talking
ticket.
forever.
It doesn't say what kind of game piece. It could be a
Have you
piece of
guys-
paper.
See the Victorious episode where they had to eat all the
Yes,
ice
that's
cream
what I
to
was
get the letters?
thinking of. I was thinking of that.
Me too.
All right. 50% of the pieces are red.
That's so cool. You put it in colors.
40%. What did you ask, Taylor?
It's so cool. You're putting it in colors. I can't write white and write. Whoa.
Hopefully you're not writing in white.
Oh my gosh, Berkeley. Do you not understand what I'm saying?
40% are white,
I didn't know colors, but she wrote yellow. Interesting.
because that's what I use for vanilla.
You did use that for vanilla. I'm just gonna use black and make it look weird.
And then 10% are blue.
So if you found a blue one, like you're pretty like well set for trying to find all three pieces, because I mean that's is 40 or 50, so I mean you're pretty much full as long as you can get a blue one.
Oh gosh, this was a mistake. Oh, actually, no, it wasn't. It was a great idea.
All right. So we're going to conduct a simulation with 3 trials to predict how many bars you would need to buy to win the prize. And then we're going to walk through each of those 7 steps as we go through.
Well, even if you buy that many, there's no guarantees.
Well, yeah, because I mean, technically, you know you have to buy 3. But in reality,
All of
it's
them could be red.
exactly.
Why all of them? Let's get one of them. Let's just have to see. It's not bothering you, is it? That was weird.
Hey, thanks. Your iPad's kind of low on battery.
It'll be okay.
My mom didn't even tell me good job.
Did she say anything?
She said, yeah, that's what I was talking about yesterday. And I was like, oh, okay. And I said, I was glad you didn't tell me. She was like, yeah. And then I was like, so what happened? And then she told me about like her going in there, and then they were like, are you excited? And then yeah. And I was like, oh, okay. And then she's like, and then I was like in study hall, I was bored, so I was looking up pictures of her like from her high school years. But how I did that is I went on this website and it has yearbooks, so I was like zooming in really close to see if I could find her. And we were like, I sent her a picture of her in basketball, and she's like, they got like all regional district, blah 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 blah. I was like, couldn't be me, could not be me, mom. You're just so good at basketball. And she's like, and I did it in track, and I was like, good for you. I'm glad you can do that for yourself.
All right, so we're going to go through and walk through these steps here one by one. So the first thing is the repeated component. Okay, so the component, every candy bar has a 1 game piece. Okay, so explain how you're going to model the components. I used a random number table. single digits only. Okay, so from 0 to 9. So the number 0 represented blue. The numbers 1 through 4 represented white. And the numbers 5 through 9 represented red. So these numbers will match the percentages. Okay, so blue was 10%. So I'm using the digits 0 through 9. There are 10 digits there, so I only need one digit to represent blue. White was 40%, so I needed 4 digits to represent that, so I used 1, 2, 3, and 4. And then I needed 50% for red, so I used 5, 6, 7, 8, 9. So I needed 5 digits for that one. So the numbers will match the percentages. And then we need to specify, will some numbers be ignored? Do you need to ignore repeats? And then use double digits for non-10 based percentages. So if you had like 35% or something like that, you would need to use 0 all the way out to 99 and then do them in groups of 2. But if you're going to do that, then you'd have to have like 0, 0, 0, 1, 0, 2 for those ones, kind of thing. Because it has to be consistent. Alright, so part 3, specify how you will combine the components to model a trial. So, for each trial, I will continue choosing numbers until I have a red, a white, and a blue piece. State clearly what the response variable will be. So count the number of trials until collection is complete. So next is run several trials. So we always want to run at least 3 trials. Okay, so we're going to run the simulation. With red, white, and blue. Okay, I'm just showing what colors I'm using here for those. okay, obviously we are still using these numbers here, okay, when we're actually going through. So basically you'll have a random number table that has a whole bunch of columns with like 5 or 6 numbers in each column, and it'll have a whole bunch of rows going down it. So you'll tell me, like, for example, if we get to like a test or something, just in case there's any issues, you'll say, I used the random number table, I used row 8. Okay, so if there's any issues, like if your answer seems like way off, I can go check it, or something like that. I'll have a couple random number tables printed off for you. If you choose to use your calculator number generator, you would just have to tell me, because there's no way for me to go back and check. You'd have to say, I'm using the random number generator on my calculator, which is what you would have told me in part 2. Okay? You would have just explained what you're using when you do that there. So, in my case, okay, and again, we'll actually run some of these tomorrow. But trial 1, 14 trials until it was complete. Okay, so that basically meant as I count across in my random number table, I kept looking for a number that fit each criteria. Okay, so it wasn't until the 14th number, okay, that's what it's asking. It wasn't until the 14th number that I hit enough candy bars to have had the 3 game pieces, okay? But then in trial 2, it only took 4 trials until it was complete. And then trial 3 took 9 trials until complete. Okay, so we've got a little bit of a range here, right? Of a gap. Okay, so then collect and summarize the results of the trials. So part 6, basically, you should talk about the mean, okay, in terms of the number of trials that it took, the median, the max, and the min. Okay, so the mean number of trials, 14 plus 4 plus 9 is, what is that, 27, divided by 3 is 9. So the mean was 9. The median, okay, meaning the middle value, was also 9. The max value that we had was 14. And the minimum value, okay, that we had was 4. Okay, but it could be as low as 3. Okay, and obviously our max could go on forever, okay, to an extent. I mean, if you got every single candy bar in the world, it could be until you get to the very, very last candy, like, you know, the last, let's say there was 100 candy bars made and you got to 89, and then on 90 you finally got your blue one. Okay, that would be a theoretical possibility. Now, I don't know that I would say it's really random if that happens, but it could go out, you know, to however the number of candy bars you have is, that you're missing one of the percentage amounts. But really, it's the minimum. We want the minimum number of trials that we have to, you know what I mean, have to run. So obviously, if we want to be more confident, we would complete way more than 3 trials. Okay, really something like 20 Okay, the ideal number of trials is 20. The minimum number is 3. Some things I may tell you you need to run all 20. Okay. But it depends on what it's asking you for and how obnoxious it's going to be. Things like that. Okay, and then lastly, state your conclusion in context. Okay, that means in context of the problem. So your conclusion, on average, you need to buy 9 candy bars to get
You're getting that from the mean or the median?
average is mean. To get all 3 game pieces. And a lot of times those aren't the same. It just happened in this one since we only ran 3 trials that they were the same. However, to be sure, you might need to buy up to 14 bars. Okay, and that was for this particular situation because the max out of the 3 trials that it took was 14 until we got all 3 pieces. But again, it could be 20 or 30 trials until you get them all. It could be 89 trials before you get them all. It just really depends. All right, so that's kind of the end of that problem. There's 2 more little note things here, and then we're done with notes. Be careful in simulations not to report something like, you need to buy 8.3 bars. Okay, and obviously there would be a ... after that. That is impossible.
Unless you break it, and then they're probably gonna be like, "Hey, you can't do that."
Round up. Yeah, exactly. They would not be very happy with you if you took 0.3 of a bar off the shelf. Okay, so just round up the value to 9. Okay, don't ever round down. Okay. You need more than 8 bars to guarantee it. You would need 9, okay, because you have that extra 0.3. This is the one situation where you round up if it's less than 0.4 or less, I mean. It's the only, well, I don't want to say the only, but it's one of the few scenarios in which you round up instead of down in that situation. All right, and then the last thing, simulations are used frequently to check the likelihood of a given outcome calculator's like frozen. So just in case you are wanting, we'll actually, go over it tomorrow, but on your calculator under your apps, okay, there's an option that says, it says like prob sim or something like that. That's probability simulations, okay. It'll take a while to load because like apps on here just take a little bit. But then it'll bring up simulation options. It'll tell you to toss a coin, roll a dice, pick marbles, spin a spinner, draw cards, okay, like playing cards, or random numbers. So that's how, if you wanted to do random numbers on your calculator, yeah, every time you hit random numbers, it's going to bring up numbers, and it'll even give you the option to tell it like you only want single digit numbers or you want double digit numbers. It'll give you all kinds of options. So and every time you do it, it'll run another set of numbers.
How do you get there? Oh.
Hit apps. Should be the purple button.
I don't have a purple button.
It's right.
It's like written in purple. Oh, mine's written in purple. I don't know if yours is.
Okay.
Yeah, beside math. And then you hit that, and then it'll bring up, you'll have to
So how do we?
arrow till you hit prob sim.
Okay.
And
you hit
then-
draw?
Yeah, basically you just keep hitting enter if you want it to keep giving you a new set of
So
numbers.
you go to random numbers.
That's so cool.
Yeah. And you can
Whoa.
change it, so like your set, you can tell it that you want numbers from such and such and such and such. You don't want repeating numbers.
Okay, no repeat.
You can tell it how many numbers you want it to give you at a time. It'll tell you, and like I said, we'll go over all this stuff tomorrow for what we want it to do, but
So fun.
it just gives you all kinds of different stuff to do, and
I think my calculator's frozen because I hit second quit. Yeah, and it's not working.
it takes a long time to load those programs up, and so it will just take a little bit. You kind of just have to sit and wait. Mine like literally kept freezing, and I kept passing it because it was like stuck.
That's so cool.
So, anyways, when we do this, I'll make sure that we, go over for sure how to do this and what we're looking for, things like that. But if you don't have the random number table or you don't want to use it or something like that, then that's fine. Sometimes on a quiz or a test, I'll say on the random number table, use row 10. So you like have to use that one specifically just so everybody's answer is the same. And I can verify that everybody knows what they're doing, and then after that problem, I'll let you use whatever you want. So, anyways.
Cool.